Alright guys, welcome back. Okay, so this one will be chapter 1, part 2. Okay, so what we're going to learn today is basically two parts. Okay, number 4 and 5. Number 4 is a deeper understanding of electrons in atoms. Okay, you need to understand how we know that the electrons basically is surrounding outside, okay, from the core. The core is made of the proton and neutrons. Okay, so in this section you're going to learn about how the electrons is going to be surrounding, okay, how they arrange and things like that outside the atom. Okay, and the second part is basically we're going to have a deeper understanding how the elements are being arranged in the periodic table elements. Okay, let's look at the number 4, deeper understanding of the electrons in atoms. Okay, right before I go into the electrons, okay, let's recap back of what we have learned from the part 1. Okay, part 1 we learned that the atoms, okay, the atoms is composed of the proton and neutron at the core, and the electron is basically surrounding it. Okay, so the more proton we have, the more electron we have. Okay, as what we have learned from part 1. So, and also we learned from part 1 is that the number of the protons determine what kind of element it is. For example, hydrogen got 1 proton, okay, it will always be a hydrogen. And 1 protons, they have, if it's electrically neutral, then we have 1 electrons, okay. So, then we also learn about the charges, okay, the properties of the atoms. For the electrons, is basically negatively charged. Okay, the mass is very, very small, okay, comparable to the proton and the neutrons, and usually they will occupy a large space surrounding the core. Okay, the core is made of the proton and the neutron, and the electron will be surrounding it. Okay, surrounding it. And then we also learn about the electrically neutral. The terminology means that no net charge. Okay, so I should actually emphasize that no net electrical charge. Okay, it doesn't mean that there's no charge. It doesn't no net charge. It means that they are charged, just that the because it's positively charged and negative charge. Okay, for example, 1 positive, 1 negative, so the net charge will be 0. Okay, because it's sort of like it neutralizes. Okay, so 1 positive, if you got 1 positive, 1 negative, okay, the net charge will be 0. If you got 2 positive, 1 negative, the net charge will be positive 1. Okay, and so forth. Okay, the next one. Okay, so the electrons will be so. As we have just only mentioned that the more proton we have, the more electrons we have. Okay, so there will be a way that the electrons will be arranged outside. It cannot be like randomly. Okay, so it's structurally the electron will be arranged. Okay, so the most standard one is that the more electron you have, so the core is like that. Okay, the core. So the more electrons you have, so it will start, okay, at first is nearer to the core. Alright, as you got more electrons, it's going to be further and further out, packed outside. Okay, and how they arrange outside, we're going to learn in the following slides. So the electrons, right, they are arranged in shell. Okay, in our shell. So we got the shell number 1, which is closest to the core, shell 1, shell 2, shell 3, shell 4, and shell 5. Okay, so from nearest to furthest, okay, from the core. So each shell, they will have a subshell. Okay, so second shell we got subshell as well, third we got subshell, fourth and so forth. Okay, so we're going to learn about that. So we got shell, so it's shell 1, shell 2, shell 3, shell 4 is get further and further away. And then the subshell within the shell number 1, it got one subshell. Then shell number 2, okay, because it got more surface, okay, so you got 2 subshells. And then when you look at the shell number 3, because of more space, so you got 3 subshell, okay, that we name as P and D. Okay, and one thing is that you must know that the orbitals, okay, orbitals is basically what is in the subshell, okay. So usually when we got one subshell, we got one orbital, okay, with S, we got one orbital. If it's subshell P, we got 3 orbitals. This one is fixed 81. If it's subshell D, we got 5 orbitals and so forth. Okay, and each orbital we got 2 electrons. It can occupy 2 electrons. So this is a system where you will learn, okay, you'll be using to know how the electrons are packed at the elements, okay, within the atom. Okay, so you can see from here, get wider and wider, okay, further, okay. So subshell 1 will be inside, okay, so you got the 2s will be further away from the core, and the 3s, even though it's still subshell s, because it's at the third shell, so it will be a lot further away from the core, okay. Either here is the core. Okay, so this one is commonly come out in the exams, okay, to draw what we call the box diagram. The box diagram is like that. So you just need to know, learn how you actually draw it, okay. So you just draw in the exam, you just draw the box first, then after that you fill up the box with the electron. So you can see from here, this is shell number 1, shell number 2, shell number 3, okay. This one is fixed, just remember it, okay. So the further away you are from the core, so here is the core, further away from the core, you have more energy because it's further away, okay. Basically when you are further away, okay, when you are further away from the core, it is less tied to the core, okay. So the electron is less tied, so it can have more energy, more freedom, okay, more freedom and energy, okay, when you're away from it. Okay, so this one is the box diagram, okay. So shell number 1, you can see, shell number 2, shell number 3. Shell number 1, you got 1 subshell, okay, this is fixed already. Shell number 2, you got 2 subshell, we name it as 2s, 2p. Shell number 3, we got 3 subshell, 3s, 3p, and 3d. Okay, so it's also fixed that for s subshell, it's always got 1 orbital, okay. S, as you can see, all 1 orbital. P, we got 3 orbital, okay. P, we got 3 orbitals, and D, we got 5 orbitals. And each orbitals, we can occupy 2 electrons maximum, okay. Okay, so this is how it works. Okay, this one is very tricky, a bit tricky. So as you fill up, okay, as you fill up the electrons, okay, then until number 4s here, you need to fill out 4s first before 3d, okay. So this is the tricky part. A lot of students write it 3s, 3p, then they start filling 3d, okay. Because 4s has a lower energy, that's why we need to fill out that one first before going to 3d, because 4s has a lower energy than 3d, even though 4s is in shell number 4, but the energy level is, okay. So let's demo over here, okay. So fill up the electrons for the following elements using box diagram. So this is a very common exam questions, okay. So please make sure you know how to draw. So if a question asks you to use a box diagram to illustrate the electrons for the atoms for the following elements, please do the following, okay. So this is how you should be doing it. Alright, so what you can draw a box until here, okay. Just draw the box until here. So you got 1s. Alright, so let's demo it here, okay. So oxygen, we have 8 electrons. Okay, so regardless of what, so what you should do is you can start doing drawing the box. Okay, so we draw 1s. Okay, then we go to the shell number 2. Okay, 2s with 1 orbital, 3 orbital. Okay, then we got 3s. Okay, 1 orbital, 3p, 3 orbitals. Okay, very important, you go to, and after that you go for 3d. Okay, which has 2, 3, 4, 5 orbitals. Okay, so when oxygen has 8 electrons, it is because it got 8 protons. Okay, so how you fill out, you use arrow. Okay, you start from S, okay, to go out, fill out from the bottom part until go up. So the first 1s is 8 electrons. 1, 2. Alright, okay, that's how we do it. We draw 1 up, 1 down. Okay, this is 1 electron, 2 electron, 3 electron, 4 electron. Okay, this part we need to fill up 1 orbital first. Okay, before we fill there. 4, 5, 6, 7, then over here 8. Okay, then we stop there. Okay, so if you draw until like that, full mark. Alright, okay, you pick full mark. Okay, so for calcium, okay, let's draw it. Okay, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 19 and 20. Okay, so calcium got 20 electrons. If we fill up the 4s, it's very common that you draw 3p here. So you just draw so I suggest that you draw the whole box first. Okay, then only you fill out. In the exam, usually we'll just cover until 3D or 4p, that's it. Okay, I won't go higher. Just need to know that you need to know about the how to draw the box diagram. Okay, how the electrons are arranged. Okay, so this one is you can see from here. Okay, different element. Atomic number is a number of protons. Okay, proton, and you can see that one proton got one proton will have 1 electron. Okay, so all these are electrons. Okay, from shell number 1 slowly to shell number 3. Alright. Okay, the last section is a deeper understanding of the periodic table of elements. Alright, so over here you can see this is how we arrange it. Okay, we arrange as groups. Okay, so it's group 1, group 2, group 3, group 4, group 5, group 6, and so forth. Okay, for here, usually for the this subject, we will go from here. Okay, group 1, group 2, because we usually will not really using the transition elements, we use here. Okay, group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8. Okay, I repeat here. Group 1, this is the common list we use. Group 2, group 3, group 4, group 5, group 6, group 7, and group 8. Period 1, period 2, period 3, 4, 5, 6, 7. Okay, so I say that what element is it? If I test you here, group 3, okay, period 2, what is it? So group 3, 1, 2, 3, okay, period number 2, so it is B. Okay, then if we say about the group 4, period 2, okay, group 4 over here. Okay, 1, 2, 3, 4, and period 2. So it's carbon. Okay, C. Okay. For the periodic table elements, usually we categorize into these three: metal, non-metal, and metalloid. Okay. The one in this purple is all metal. Metalloid is here, and non-metal. So when you're talking about metalloid is have a property that is somewhere bridging between a metal and non-metal. Okay. All this like transition not transition, the what we call the silicons. Okay, we use it in our computer chips. Okay, semiconductor, they have both the metal and non-metal properties. Okay, and all this are what we call the metalloid, and non-metal and metal. So if you're looking at the properties, metal usually is very high thermal and electrical conductivities, which means that it can conduct thermal. So if you put your hand to one end, so this is the metal. So if you put electric current here, the electric current will go from there to the other side. Okay, or if I hit this part, okay, okay, the heat will travel until the end. Okay, so this is what we call conductivities. High malleability, again, means that it can bend the shape. Okay, metal can bend the shape. Okay, and yeah, of course you need a lot of force, but it still can bend the shape. It won't break. Okay, a metallic lusters. Okay, very shiny. Non-metal. Okay, non-metal usually is very brittle, like carbons. If you try to like bend it, okay, you just crack. Brittle, and usually is in the powdery, solid, or gaseous state. Okay, and all the properties are totally opposite the metals. Metalloid, as I mentioned, is somewhere between the property between the metal and non-metals, and what we call semiconductors. Okay. Okay, the trends in the atomic radii. Okay, you can see from here, the radius of the atoms from here, it decreases. Okay, this is the same trend. Here increases is because getting more and more shell. Okay, shell getting more and more shell 1, shell 2, shell 3. Okay, as you have more shell, of course, will be bigger. Okay, radius means that how big is the elements. Okay, but interestingly here is that why is it decrease over here? If you notice that if you go from group 1 to group 8, okay, actually there's an increase in the there's an increase in the number of proton. Okay, also a number increase of the electron. But why is it supposed to be like getting bigger, right? But why is it like the radius like get smaller? Okay, the reason is because over here, okay, you will notice that they are in the same shell. Okay, although there's an increase in the number of proton, but they increase in the same shell. Okay, because it's in the same shell, they got more electrons. When they got more electrons, they will get more attract. Okay, the electrons get more attract into the core. Okay, because of that, okay, they will have slightly decrease. But the moment they go to the next shell, they will increase. Okay, so within the same shell, when you got more number of proton electrons, they actually will have smaller radius. Okay, but the moment you go to another period, which is because of increasing the number of shell, okay, then you got bigger. Then within the group, okay, it's smaller. Okay, when mesh to move the next period, go bigger. Then go down the group, you go smaller. Go down the next period, go bigger. Smaller, bigger. Okay. Alright. That is what I mentioned, yeah. Okay, so if there's no more questions, okay, so I will stop here. Alright, so do make sure in the any question, please ask in the Padlet. Okay, and please also complete the tutorial, and we will discuss more on that. Okay, alright, thank you.